everyone! In this video, we will be discussing all about the confidence interval. So, let's begin. So, a confidence interval provides an estimate of the range of values that the true population parameter is likely to fall within. The level of confidence is typically expressed as a percentage, such as 95% or 99%. For example, a 95% confidence interval for the mean would suggest that we are 95% confident that the true mean falls within the range of values calculated from the sample data. So the calculation of a confidence interval depends on several factors, including the size of the sample, the standard deviation of the population, and the desired level of confidence. So generally, larger sample sizes and lower levels of confidence lead to narrower confidence intervals, while smaller sample sizes and higher levels of confidence lead to a wider intervals. So when and where can it be utilized? So confidence intervals can be utilized in various fields where data analysis is performed and population parameters need to be estimated. So the first one is in scientific research. So for example, if a study is designed to test the efficacy of a new drug, a confidence interval can be calculated to estimate the range of values for the true effect of the drug. So the next one is in business and finance. So for example, in business and finance, a confidence interval can be calculated to estimate the range of values for the expected return of a particular stock or portfolio. Next is in quality control. For example, if a manufacturing company produces widgets, a confidence intervals can be calculated to estimate the range of values for the mean weight of the widgets of produced. And lastly is in public health. For example, in public health, a confidence interval can be calculated to estimate the range of values for the prevalence of a particular disease in a population. So overall, confidence intervals are a useful tool for estimating population parameters from sample data and for quantifying the uncertainty associated with these estimates. So they can be applied in various fields to make informed decisions based on data analysis.
So, here are the problem of confidence interval. Suppose a researcher wants to estimate the mean weight of a certain type of fruit. They take a random sample of 50 fruits and find that the simple mean weight is 200 grams with a sample standard deviation of 20 grams. Construct a 95% confidence interval for the true mean weight of this type of fruit. So for the solution, to construct a confidence interval, we need to first determine the margin of error and then add and subtract it from the sample mean to get the lower and upper bounds of the interval. The margin of error is given by at 95% confidence level, and the z-score is 1.96, which can look up in a z-table for use a calculator. Plugging in the values, we get margin of error equal 1.96 times 20 divided square root of 50 is approximately equal to 5.58. So, the 95% confidence interval for the true mean weight of the fruit is lower bound equal sample mean minus margin of error equal to 200 minus 5.55 approximately equal to 194.42, and for the upper bound, a sample mean plus margin of error is equal to 200 plus 5.58 approximately equal to 205.58. Therefore, we can say with 95% confidence that the true mean weight of this type of fruit is between 94.42 and 205.58 grams.
Other applications: sample size determination, hypothesis testing, meta-analysis, and survey research. Sample application: by specifying a level of confidence and a desired margin of error, a researcher can calculate the minimum sample size needed to achieve the desired level of precision. Hypothesis testing: used in hypothesis testing to determine whether a population parameter is likely to be equal to a hypothesized value. Meta-analysis: by calculating confidence intervals for the estimates from each study and weighting the approximately, a meta-analysis can produce a more precise estimate of the true population parameter. Survey research: by calculating a confidence interval for estimate, researchers can determine the level or uncertainty associated with the estimate and make informed decisions based on the results status.
So our conclusions is that a confidence interval provides information about the likely range of values for a population parameter based on a sample of data. So the confidence interval includes a specific value. If a confidence interval includes a particular value, it suggests that the true value of the population parameter is likely to be close to that value with a certain level of confidence. For example, if a 95% confidence interval for the mean weight of widgets in a production process is 20 and 25, we can conclude that 95% confidence that the true mean weight is between 20 and 25.
Conclusion: the confidence interval does not include a specific value. If a confidence interval does not include a particular value, it suggests that the true value of the population parameter is unlikely to be close to that value with a certain level of confidence.
Conclusion: the confidence interval is narrow or wide. Wide of a confident interval provides information about the precision of the estimate. A narrower confident interval suggests that the estimate is more precise, while a wider confidence interval suggests that the estimate is less precise. Thank you.